I'm Dean Safola, and this is the Azure Academy. Last time we talked about our first virtual network, and this time we want to dig into virtual machines. Now, there is a lot to cover on VMs, but we're only going to talk through some of the basics in this video. So, what is a virtual machine? So a virtual machine in general is a emulation of a computer system. VMs are based on computer architectures, like if you heard of the x86 or x64 architecture, and basically provides the same functionality as a physical computer. So in Azure, a VM runs on a physical host server that is in our Azure data centers, and a VM is a resource, and like all resources, it lives in a resource group. A VM is made up of CPU, RAM, network interfaces, disks like an operating system disk, data disks, etc. So let's look at our Azure portal and let's start building our first VM. So here we are back in the Azure portal, and we've got our Azure Academy resource group where we created our first virtual network called VNet. And we're going to start off with creating our VM by clicking on Add. So here we are back at the Azure Marketplace, and we have many different kinds of virtual machines that we can create, or virtual appliances, operating systems that run in the cloud. With these things could be from Microsoft, Windows servers. They could be Linux distributions from Red Hat, Ubuntu, SUSE, many others. They could be virtual appliances like firewall appliances from Cisco or Checkpoint or Palo Alto. They could be storage appliances. Many different things that you can explore in the Azure Marketplace. But today we're going to start off by building a Windows server, and we'll pick right here Windows Server 2016. And this will be a resource manager model. Remember, we don't want to deploy classic if we don't have to. And we'll hit create. Okay, so there's a few menus that we have to go through here. We have to fill out the items that are here so that we can build our virtual machine. First thing we have to do is we have to give it a name. So let's say the Azure Academy 2019. And now we have to choose what kind of disks. So in Azure, we have the choice of using hard disk drives or SSDs, which would be more performant. So what kind of drive is going to be good for your workload? Generally speaking, I would recommend that the operating system disk should always be an SSD. Okay, you want to get that good snappy performance on your operating system. And then for your data disk, if you don't need a lot of performance, but you need capacity, you can still use hard disk drives. There are different tiers of storage that we provide in Azure. The way it works is based on the size of the disk that you provision, puts you in a different tier on that SKU. So if you provision a drive that's 32 gig, you'll have less maximum possible IOPS than a drive that's 4 terabytes. Okay, so you just have to size it correctly for your workload. So right now we're just going to go with an SSD, and we have to give the box a username. Now in Azure, because we're dealing with the public cloud here, generally we want to keep these things as secure as possible, so your well-known first administrator role names are not valid. So if I tried to type in here administrator, it's going to complain, say that it doesn't meet the requirements and I need to choose a different name. So let's try admin. Doesn't like that either. Well, what if it was a Linux system? Nope, doesn't like that either. So it wants to be something that is not common, so it can be more secure, and people would have to guess what your username is instead of giving them something common like admin or root, where that's already one thing that they know and they just have to figure out your password. So we want to make it as difficult for the bad actors as possible. So I have a username that I sometimes use. And then same thing on your passwords. You can't have a password like if I type password, say that it must meet these particular complexity requirements. So something common or repeating characters is not going to be valid. So you need to have something that you can type and remember that is the right complexity. Okay, so moving on. So we have to put this resource in a subscription and then inside a resource group. So we'll put it in our Azure Academy resource group, and then we'll build this resource in the central US. Now down here, we have one of the ways that Azure tries to help save you money, especially if you're using other Microsoft products, is that when you build a VM, you're paying really for two things. You're paying for the virtual machine itself, the compute, the RAM, the storage, all that. And then you're also paying for the license to run that operating system. And same thing for like how we have our Windows SQL SKU that you can build. It's a VM plus SQL. So now you're paying for the compute and you're paying for Windows and you're paying for SQL. Well, it would seem that since you're already paying for these licenses somewhere else, that we want to give you the option to say that you're already doing that and we want to save you the cost of those licenses. So you can say here that you already have a Windows license, assuming that you really do, and I do, and then you confirm, so you are validating this, and we will do a true up with you according to the normal licensing true ups that happen, and we'll see what you run in Azure and where you're using your licenses. So in the end, we know that everything's going to be above board since I have licenses, so I will click OK. Okay, now we get to choosing the size. Now, what is a VM size? So this is where we talked about CPU and RAM. Um, this is where also we limit the number of data disks that you can have on a particular VM SKU. We limit the number of maximum IOPS that are available to that VM SKU, as well as local storage. So the other thing when we picked SSD storage instead of HDD storage is we get local SSD storage on our VM, and we'll see this when we boot up into our VM. We have our operating system drive, which in Windows is the C drive, and then we have a D drive, which is temporary storage. This is what this local SSD is referring to. It's storage on the physical local host. This is temporary storage. This is throwaway storage. This is volatile storage, meaning that anything that you put in here could be lost when you reboot. Okay, so it's a good place to put something like your SQL temp DB, but not your actual SQL database, okay, because it could be lost when you reboot. Now, we also have something in here that are called zones, and these refer to availability zones. And an availability zone happens at the Azure region level. So inside a region, we have data centers. Each one of those data centers could be in one or multiple zones. And that's just another way for us to extrapolate out the layer of high availability that we're providing. And they're being rolled out soon. So there's another thing that we can look out for things that don't have zones, which we'll do in a second. But for right now, you can also see pricing here, and I'm just going to pick the cheapest VM possible because this is just an example. Okay, so here's that high availability section I was just talking about, and we can select our zone. But the other option we have is an availability set. So what is an availability set? So when you go into availability sets contain fault domains and update domains. So a fault domain is a rack. It's a rack of servers, okay? And if that rack were to go down, your workload that was running on a server on that rack would also go down. Now this is bad. Last thing you want, you're up here paying for your services to be running in Azure, is for it to be down. These things still do happen, faults do occur, and so we provide a high availability functionality in these availability sets, and the fault domain says how many racks of servers do I want this particular workload to occupy. So let's assume for a second that I had 5 web servers. Okay, so if I have 2 fault domains and I have 5 web servers, that means that my workload of web servers is going to be spread over 2 racks. So if one rack goes down, the ones web servers that are running on that rack are down. The other ones are still up, so my services are still being provided to my end users. Update domains, we give you a lot more of those than fault domains because these are not racks. These are servers that are inside those racks spread across multiple racks. So what we do when we are upgrading the servers and patching our servers on the Azure host fleet is we have these groups of servers that we will patch at once, spread across many different racks, and there's a way that we allocate those things so that we're taking down things in the most highly available way possible. So in the case where I would have 5 servers in my web server example here, and I have 5 update domains, that means each server would be in a different update domain. So when host 1 goes down, then VM1 will not be available, but 2 through 5 are. Same thing with 2 going down. And so that way you only get 1 server down as possible. Now, with update domains, if you have 10 web servers and 5 update domains, then you have the risk that 2 of them could be down at any one time. Okay, but the service itself will still be up, and that's the idea here. So it is also a best practice at this point that every server live in a availability set, even if you're only allocating 1 server of a particular type for a particular workload, because you cannot add a server to an availability set later. It has to be done when the system is being created, and that's because of how our orchestration engine handles the allocation of VM resources on our hosts. So I'm going to create an availability set here. So we'll say that this is the Azure Academy AV set. Okay. So now we come to the storage section, and it says use managed disk yes or no. So what is managed disk? So in the older versions of Azure, we had storage accounts, and that's where all of your disks would live. Now, these storage accounts had a certain number of maximum IOPS limits that they had, and you had to take care of how many disks you allocated between OS disks and data disks, and how many of them were being really chatty, and which ones were on what storage account so that you could balance all their performance. And this was really a big hassle. So what Microsoft did in the managed disk service is we said, you know, we're going to extrapolate all that away from the user and give the user the option to just check yes. And yes means that all you get are disks. You get disks with predefined performance metrics, and we, as the cloud provider, will manage all of the disk performance. So it makes everything simpler for you. You just get a disk. The disk performs the way that you asked for it. So everything should be using managed disks. The only possible exception to that may be some kind of network virtual appliance or storage provider appliance that does not currently use a managed disk. Okay, but besides that, everything by default, best practice, use managed disk. Okay, so now we come to the network section. Now, you may not have noticed it earlier, but when I deployed this VM, I chose the central region, and I did that on purpose here. So in our previous video where we created the virtual network, we created it in the East US region. So this VM is being created in Central US. And of course, you can build a resource in whatever resource group you want in the same subscription. It does not have to be within the same region. However, the virtual network does have to be in the same region as the VM. So right now it's telling me that I could provision a new virtual network because none exists in the central region for me right now. Okay, so I'm not going to do that, but I wanted to have that as an example for you. So if you run into that in the future, it's because you're trying to provision a resource, in this case a VM, where the virtual network or whatever other resource does not exist. So I'm going to go back to basic, and I'm going to set this to our Azure Academy and set this for the East US region. Okay, and then we will go back and we'll select our VM size again. Okay. Okay, and there, it already defaulted to our VNet. Okay, so that's good. Now, in our VNet, we have subnets, and these are the same subnets that we had provisioned last time. Notice you cannot deploy a VM to a gateway subnet. We'll get into more of that later. Right now, we're going to provision this to the management subnet. The VM will get the first available IP address in that subnet. And if you want, you can set a static DHCP reservation so it always will have that address. Next, we have public IP addresses. Now, I talked a little bit about this in the last video, especially when we were talking about DDoS protection. So, public IP address means that I'm going to enable this particular system to be accessible from the internet. Okay, so the VMs in Azure can always get out to the internet. We provide that SNAT or network address translation from your virtual network out to the internet, but nothing can get in. Now, when we add a public IP address, things will be able to get in. So we need to take some care in how we do this. One of the things that you can do, like we talked in the last video, is you can enable standard DDoS protection, which would apply DDoS protections onto your virtual network and to your public IP addresses. So you don't have to do that. That's just another service that we provide you if you would like to take advantage of it. In the case of what we're going to do here, we are going to give it a public IP address. We only are using basic DDoS protection, but we're also going to enable the next item, which is a network security group. Now, a network security group is not exactly a firewall. It's more like an access control list. So a network security group functions based on what's called a 5-tuple rule set. And the 5-tuple rule set basically looks for your source IP address, your source port, destination IP address, destination port, and protocol. And if any traffic matches the rule set, we allow the traffic. Okay? NSGs are great because they require no overhead whatsoever. There is no latency, there is no additional performance impact of using an NSG. The downside of the NSG is it is a simple access control list. It's a rule set. If you match, you're in. If you don't, your traffic is dropped. Okay, so in the VM experience here, we have two ways that you can allocate this. You can do basic NSG or advanced. Now, this does not change the NSG that you get in the end. Okay, the NSG that you will get in the end is exactly the same. What we're providing here in the portal experience is simply, do you want a well-known port enabled, like for RDP? Or SSH or web traffic or MS SQL. If you do, you can check this. So I'm just going to enable RDP, because I'll show you in another video how we can secure this a different way through the Azure Security Center. And it says here these ports are exposed to the internet. Use access controls to limit the inbound IP addresses, and we're going to talk more about how to do that later. So this next section, we're going to just talk about very briefly. This is extensions. So in an extension, these are things that we add at the Azure Fabric layer and manage at the Azure Fabric layer, which will inject code of some kind onto your VM, and we will run either software or run scripts or things like that. So when you go to add an extension, here's the list of all the extensions that we have. So you can do Puppet or PowerShell or a custom script. You want to run a batch script, or you just want to run a PowerShell script or a shell script of some kind. We have other things in here for Chef and other management tools. CloudLink, which provides data encryption services. Anti-malware and other antivirus services can be added, and there's plenty more that you can look at. So for right now, I'm not going to load any extensions, but just wanted to let you know that they're there, and we'll dig into extensions at a later time. So this next one, Auto-Shutdown, I am definitely going to enable this, and the reason why is Auto-Shutdown will allow my system to turn itself off at the time that I specify in whatever time zone I specify. Now this is great because if I'm running a system that does not need to be running 24/7, when it's off, I'm not paying for it. That's one of the great things about the cloud. We didn't really have to think about this in the traditional data center model because we're already paying for the hardware and the electricity and the cooling because we got to run the whole data center. So it didn't really matter. Let it run 24 hours a day. Nobody used it for, at least 14 of those hours, but didn't really matter. In the cloud, it matters. If nobody's using that box for 14 hours, we're paying somebody for 14 hours worth of compute that nobody's using. Okay, so using things like auto shutdown is a great way to help save you money in the cloud. Next, we have boot diagnostics and guest OS diagnostics. So these are some monitoring features. Monitoring in Azure requires a storage account because we have to have somewhere to put all the files that we're building for these diagnostic purposes. So I'm going to enable both of these, and I'm just going to take the default name that's here. So this Managed Services Identity section, or MSI, is a new Azure service, and this integrates with Azure Active Directory. And basically what it allows you to do is create a service principal in Azure, which is like an Azure Active Directory application, and grant that service principal access to your VMs and grant it a certain amount of RBAC enabled controls. And RBAC is role-based access control, so that I can say that this service principal has the permissions to do XYZ on my VM. Right now, I'm not going to enable that. We'll deal more with Azure Active Directory at a later time. Then we have backup. Now, backup refers to, in this portal experience, the Azure Backup Service. And we'll get into that more in another video, but backup, as you'll see, as well as some other things, are integrated into the Blade experience in the portal. So we're not going to enable this for right now. Okay, and then like with all VM creation in the portal, we get a summary of what it is that we have selected to do, as well as a link to look at our template and our parameters file and download those for later use. But right now we're just going to hit create. Okay, so our creation process is off and running, and you can click on it in here in the notification and look at the deployment progress. We can also go back to the Azure Academy resource group in our breadcrumb trail and monitor the deployment from there, or we can just go and do something else. So for right now, we're going to monitor this deployment a little bit. And as you can see, within a few seconds, it's already provisioned a few resources. And now it looks like we are provisioning our virtual machine. So just want to show you a few things here because this looks a little different than the last time we looked at it. Here's our template that we were deploying, and you can see these are all the string or secure string values, and all of those values are stored in our parameters file. Okay. And then in the outline here, we can see the different types of resources that we're deploying. So this is the layout for deploying a virtual machine. And we have basically the type of resource it is, and then the name of that resource, a API version, where this resource is located, and then we have the properties of the resource. And that's the same basic layout for every resource that gets deployed in Azure. There's an operating system, so we have a profile for that OS. If this was a Linux operating system, this would be a Linux configuration. Hardware is what VM size did we pick. The storage information was what image were we using. You can use custom images that you have and manage, or you can use images from the marketplace. Deployed our OS disk. We didn't deploy a data disk in this case. And then we had our network interface. So we link all of these pieces together, and in the end, we end up with a virtual machine made up of all these components. So then further down, we had the virtual machine extension for diagnostics, and this is the guest OS diagnostics that we were monitoring. And then we had our resource of our availability set that we had created that had our fault domain and update domain settings. We had our shutdown, our auto shutdown schedule, which we had set up, and that was this section here. And then we had the storage accounts needed for our diagnostics. We have our network card interface, and you can see that our IP address allocation was dynamic, and you could set that to be static, and that's how you would set this static DHCP reservation, and you would set a static IP address as part of that. We linked this to our public IP address that we provisioned, as well as to our network security group. And then we provisioned our public IP address, our network security group rule with RDP that we had set up from before. Now, one of the things that might take your deployment a little longer than the 4 minutes that it takes on average, like I said, is having additional resources as well as adding dependencies. Now, you may not have seen it as we were going through the template here, but some of these, here we go, some of these resources had this depends on section. Now, when you say that a resource depends on another resource, that means that the template logic understands that the other resources have to be provisioned before this one. So if you take the resources and you can list them here on the template in any order you want, that is completely irrelevant. But it's the depends on that actually provides for the sequencing of the resources in what order they get built. So any resource that has no dependency, like our availability set, would be provisioned first. Resources that require the availability set will not be provisioned until the availability set is complete. And as you can see, our virtual machine resource relied on the availability set and the network card and the diagnostic storage account to be created first. So if you add up all of the resources and then what those resources actually depend on in order to do their configuration and setup, then that's what will take longer. Okay. Now, this particular resource that we're looking at here, the one with the big long list, this is our extension for doing OS monitoring. It requires that the VM be configured and online first. So you could look at, that's 4 minutes right there. Then you add the extension on top of that, which will be another few minutes because it's an extension. It's something that has to download from Azure into the VM, do its installation, and then you can move on to the next thing. Same thing with the schedule. The VM had to be deployed first before we could deploy a schedule. Okay, and you could just see that as you go through the template. Now, the one other thing at the bottom here is we do have an output, and the output is going to be an admin name. Now, right now, there is no output. Now, the reason for that is our deployment is still going on. Okay, so if we look at our deployment, right now, we've provisioned everything except the diagnostics extension, which does take a little while to set up. So I'm going to pause the video here and we'll come back once that's done and we'll verify our output.